start recording. And of course, I forgot to start recording, so I'll just reiterate what I just said. We're getting right near the end of the course. There's only 6 full working days left, so make sure that you're working hard to complete or revise old assignments and hand them back in. Make sure that you are preparing yourself or have prepared yourself for the second Python exam, and write that as soon as you're comfortable. But remember, it needs to be handed in by midnight next Tuesday, sorry, which is the 27th of April. And final projects are coming up, so those should be well in hand by now. And also, there's 2 additional assignments. One of them is a careers assignment, and one of them is a basic history of computer science and programming and the history of computers. And those are not large assignments. Those should take you probably no more than an hour each, I would say, even on the high end. So make sure that you've done those and submitted those. And we've gone through all of the concepts included on the second Python unit exam over the last 3 or 4 live sessions. We've done multiple examples of everything on the concept lists. So if you're studying for the exam and you're going through that concepts to review list that I've posted for you, and you're not sure about some of the terms, you're not sure how to do some of the things, make sure you check the live session videos, which I have recorded and posted in Module 4. And likely what you're looking for is in there. If you have any questions about a particular concept or why I did something in the video, or how it applies to an assignment, or something's just not working, please continue to email me and I'll continue to point you in the right direction. So are there any questions before I do a little bit on 4.8, which is try, accept, basically sanitizing data? All right, not seeing any questions. So what I'm going to do is the normal. I'm going to share my screen, and we're going to look at building an example inside PyScripter. And as always, I'm going to encourage you to open up your IDE for Python and type along with me, and maybe try your own examples or whatever you feel will help you best practice your skills, and we'll take it from there. Everybody see PyScripter okay there?
Yep.
Good. Okay, so you may hear these terms thrown about in computer science or programming or user interface design, called data sanitization or sanitizing data entry or sanitizing inputs. All this means is that when you're taking in data from a user, or when you are programming something or entering data, you want to make sure that the format that data is in is appropriate and that it doesn't break your program. So for instance, I remember hearing about a case where there was an online school system that was essentially their databases were all deleted because somebody had used an entry form on one of the websites, just a normal sort of enter your name form, and they had put some specific code in there. I believe it was a database program called MySQL, and they had put in some specific code and hit the submit button or whatever it was, and that data wasn't sanitized or checked in any way. So when it went into the database, it actually executed a command that deleted all the files and all the material they had stored in there. So there's an instance where a lot of work and a lot of data can be compromised if you don't check the inputs that people are putting in. And other times it'll break your program, or it'll cause Python to stop working, which obviously is not good. You want to have a way for people to enter the information that your program needs, but you also want to prepare for the fact that people make mistakes and people don't read instructions, people put in the wrong data, and it can't break your program. You have to have a program that's going to be flexible enough to either get them to enter the data again, or at least inform them in some way that their data is incorrect. And one of the ways we can do that in Python, probably the easiest way, is to use the try and accept blocks. And there's a whole bunch of stuff you can use within try and accept, and finally commands to sanitize and check your inputs. But we're just going to do the very basic stuff for now. And there actually isn't included in assignment 4. Or assignment 13 because it was just a little bit late, and I wanted to make sure we had time for preparing for the exam and whatnot. But I think there might be one question or two questions on the exam, but it is important that you're exposed to it and get a little practice with it. So when we're dealing with try and accept, essentially you've seen syntax errors and errors where you've entered data or your code is not working for some reason, and you get the big red error, the big red syntax error saying, you know, I can't do this with an integer, I can't do this with a float, or my program broke for some reason because of something that was either saved as a variable or something that somebody inputted as data. And I'll just show you, you know, a couple of examples of this. So if I've got, maybe I've got a equals high and b equals 5, c equals 6.7, and d equals 0. I'll just show you a couple of the errors that could possibly happen. So what happens if I try to print 5 divided by 0, or 5 divided by 0, and in this case b divided by d, which is the same thing, 5 divided by 0. I'm taking a 5 and I'm trying to divide it by 0, and we should know from our math class that that's an undefined situation. You can't divide by 0 because the universe collapses in on itself. So when I try to run this program, I get the, you know, I get the predictable red error code trying to tell me, hey, there's a problem here, and there's a very specific problem. It's called zero division error, and it's just the computer telling you, hey, you try to do a mathematical operation that is, you know, it doesn't exist, it's undefined, therefore my program breaks. So whatever you had after that in your program is not going to work. So if I wanted to, you know, just put a little print program over, after that, it's never going to reach it because it's going to have an error on line 9. It's never going to get to line 10. So your program is not going to continue and it's not going to finish. And that's unacceptable if you've released something to the public that it breaks like that. It's not doing what it's supposed to do, and it doesn't sanitize the data or check the data or validate the data the way that it needs to. Okay, so there's ways that you can protect against this, and one of the easiest ways to protect against this is using something called a block called try and accept. And basically, the first part is just the try. So it's as simple as that. It's like, what do you want me to try to do? And in this case, I want you to try to print b divided by d. And actually, what I might do here is I might do some inputs just to demonstrate that this can be, this usually is data that's entered by a human being. So I want a human to enter an integer. For the sake of this example, we'll just pretend that they are capable of entering the integer properly. The problem is going to be that they're going to try to divide by 0. Right, so when I run this program, if they give me a valid integer for b and they give me a zero for d, it's going to run this and it's going to say there's an error, program, it's not going to get to the program overline. So that's what happens when I do a try and then I do an accept. And the accept is printing that is not the correct data. Okay. And then it'll print program over at the end. So if I put in data that's acceptable, so enter an integer, 5. Okay, let's say I ignored the enter 0 and I put in a 1. It's able to run the statement that says print b divided by d. So it goes in and it tries to do. So whatever is under the try, it's going to get to. It's definitely going to try to do this line. But if it's successful, it's going to skip over the accept part. So it's not going to run this, and it's going to run the program over portion. So it's a bit like an if statement in that, except it's going to try to execute this line, and then it's only going to run the accept if it can't. And if everything's okay with the try, with the try block, then there's no error in the program. The program keeps running, so you fixed the problem. In this case, there was no problem because I was able to enter an integer and then another integer, and the computer was able to divide those integers and give me an answer. But what happens if we put my program into a situation where I do get an error? Okay? And we've already seen this error. If I enter 5 for this particular input and I enter 0 when it says enter 0, and then I try to divide those numbers, okay, you'll notice that it did not print 5.0 or any number because 5 divided by 0 is undefined. So it did actually execute that line, but then Python picked up that it was causing an error. But instead of telling me what the error is and stopping the program, it says, okay, we have an exception for this. when this doesn't work out for any reason and it causes a syntax error or a runtime error, then we go down to the except. And as long as this is formatted properly, then your program will continue to work. So in the except case here, it says print that is not the correct data, which it does. And then it does, as you can see, continue on to the next line of the program, which is program over. So even though I put in bad data, it didn't break my program. Now, this does assume that what you've got programmed in the except portion is illegitimate data. If I try to do b divided by d in the except portion, well, it's going to fail on try, so it's going to move to except, and then it's also going to fail on accept, so then it's going to break again if I enter 5 and 0, okay? Because basically the little check that you put in for the error, or this is what you do if you find an error, is also an error. So you got to make sure that whatever's in your accept portion is correct. So this is, I'll just say this is bad data for whatever reason. So this is one particular error you get, and it's actually programmed in as a divide by 0 error. So division by 0 is an error, a special error, and there are different types of error built into Python, and you can actually have different exceptions based on what kind of error it was. So if it's a 0 division error, you can have it specifically say you're dividing by 0. That's not the only type of error that we can find. So in this case, it might be except 0 division error. There it is. Again, the code completion on this is great because I didn't have to type all that in, right? I just had to type in ZE, and then there it is. The only thing that matches ZE is 0 division error. So if there's a 0 division error, it's gonna give me this error. You are trying to divide by 0, but there's other errors too, and I'm just going to go grab another one of those errors. I'm just going to go check my PowerPoint and grab something that is easy to replicate. Let's try a name error. Okay, so except name error. Okay, so there's a name error as well. And then we could print something like this variable does not exist. Okay, now, so I've got two different potential errors that I could catch. And what's going to happen is if it's not either one of those errors, then your program will break. So in this case, when you're specifically putting an exception in for a name error or a 0 division error or a type error or a runtime error or something like that, you have to make sure that you kind of cover all your bases, because if it's not one of these two errors, it's still going to break my program. So when I run my program here and I try to do my b divided by d division with 5 and 0, okay, it says you are dividing by 0. It says you're dividing by 0, program over. So what happened there was it checks the errors from top to bottom. As soon as it gets the error message from this internally, it goes down and says, okay, I found a 0 division error when I tried this try line. Does it match any of these exceptions? And it happened to match the first exception, which was the 0 division error. So it printed that message. It printed the, hey, you're dividing by 0 error. If it gets a different error, for instance, if I try to, let's say I try to divide by the variable e, there is no variable e, right? It's not up there. So when I run my program and it asks me for an integer for, what is that, b, and I'll put in 5. It asks me for an integer for d, I'll put in 1, or 81, whatever. And then I try to run my program, you'll notice I got a different error now. I got a variable, or I got a message that says this variable does not exist. And the reason that I got that error is because that's one of the things, that's what a name error is. When it was trying to find the e variable and the data that was associated with e, it went up here and it knows there is no e. So I don't know how to divide by e because I don't have a variable and I don't have any data for e. And that's a specific error called the name error. Now, because my program was equipped to handle that, because I had an exception for name error, then it printed this specific message. It says this variable does not exist, and then it continued to program over. So once again, the user made an error, or the programmer made an error, but the program didn't break. Okay, it was built to handle the error and continue on. So let's say you had another 100 lines after this try block, it would still try to execute those 100 lines instead of just breaking right here. We only have one line after, but it's just to demonstrate that you need to be able to get to the program over line to indicate that your program will continue after whatever the input is. So those are two specific types of error, and there are many others. But make sure that you've got them. Make sure that you've got your separate messages for the specific types of errors. Another error is if you try to do math with a string and a number, like divide by a string, it won't let you. So if I take my A, which is a string, and I try to divide it by, let's say, D, and I'll make that one a float. Probably don't need the C. We use inputs for these because usually when you're testing data or sanitizing data with try, you're testing things that people have entered. So we're going to get an integer, and we're going to get a number, and A is going to be a string. So A equals str input. Actually, I don't need to do str because remember, by default, inputs are strings. So I'll just get the input of enter a string. And then we'll try to divide our string, which is A, by, it doesn't matter, B or D. Let's just do it by D in this case. And it's going to cause an error because I don't know how to divide, and the computer doesn't know how to divide a word or a sentence by a character, or sorry, by a number, float or integer. All right, so let's run it, and let's enter a string, and our string is going to be hello. Let's enter an integer, 5, and let's enter a float. We'll do 6.5. And now you'll notice I get an error. Okay. Now, even though I had a try and accept structure set up, what I didn't have covered was a type error. So I took care of a zero division error, and I took care of a name error, but I didn't specifically take care of a type error. And it tells me there's an unsupported operand type. That's just math, right? Unsupported operand type in this case would be division for a string and a float. So that line there is just telling you Python is not equipped to be able to divide a word by a number. It doesn't know what that means, and that is a type error. So because we didn't specifically have the type error taken care of with an exception, with the except block, it still broke. All right. So you can have catch-alls so that you look for specific errors, you look for specific exceptions, and then you can have one at the bottom that kind of handles everything else. So perhaps I could have except, and then in the bottom, something to the effect of print. There's a problem. I don't know what it is. Okay, so in this case, even though I don't have a specific exception for type error, because I've got one blank except here at the bottom, it should catch anything that wasn't covered by the first two. So I'll try that same sort of process again. Our string's going to be hello. Our integer is going to be 5, and we'll try to divide by 6.7. And you'll notice that the message that I get is there's a problem. I don't know what it is. And then it says program over, which means it got to the last line of our program. So even though my error didn't match this error and it didn't match this error, because I had a blank one in there, it's going to clean up after these two. So if it isn't one of the top two, then this one's kind of built to handle anything else. It basically says, we know there's a problem because the computer generated an error, Python generated an error, but it doesn't fit into either of these two categories. So instead of giving them a specific message about your variable or a specific message about you trying to divide by 0, I'm just telling you there's a problem and we don't know what it is. But the point is, you identified that there's a problem and it didn't break your code because it'll still go on to run anything after that. So you can have as many as these as you want. There's, I don't know, there's maybe like 20 built-in errors that happen in Python commonly. I put the most common ones in that presentation and the video for 4.8. But these are the ones you run in most common. You run into zero division errors and name errors and type errors, and sometimes just runtime errors where the program doesn't even start. And aside from that, you're not going to see too many other errors until you start diving a little bit deeper into Python. You can also check for multiple things with one line just by throwing a comma in it. So if I wanted to check for both zero division error and name error on the same line, it worked anyway. I don't know why it's telling me that there's a problem there. Invalid syntax. feel like that should work. I'm not sure why that's good or not. You know, let's use the comma. Maybe you have to use an and. I could have sworn that the comma used to work. Let's try or. So in this case, I don't have a syntax error, so hopefully it's going to work. I would be checking for a type error or a name error, which means it could be one or the other. It doesn't have to be both. Well, it can't be both. You can't have both a type error and a name error at the same time. But the reason I did this is because you could kind of catch two things at once and say, you know, you either are missing a variable, or for the type error, or you tried to divide. So I can make a specific error a message just that covers these two, and then this one would cover everyone else. So instead of having, if you can sort of describe the error with one message, you can put multiples in there. So let's see if I can generate a name error here. So I'll do, or a type error. So I'll do a string with hello, and then we'll do a integer, and then we'll do a float. And now you'll see that it generated the you are either missing a variable message because what the data that I entered would have been a type error. So this exception caught the type error. And if I change this so that I try to reference a variable e that doesn't exist, then it should catch it with the name error and give you the same message. So if I do hello, and then I get a good data, I get it, you know, 4 and 1 or 2 or whatever. Oh, it said I didn't get a name error. It should be a name error. Type error or name error. Let's check this again here. Yeah, okay, so it catches it there. Except name error. Oh, I think I know what it was. Maybe you have to put the except in again. No, I guess not. Name error or except type error. Work? No, it doesn't let you do that. Okay, I'm missing something obvious because I know I've used the comma before to use multiple exceptions on one line. I'm missing some sort of syntax. I can't, because or didn't seem to work there when I did the name error or type error. It seemed to do the first one, but it didn't catch the second one. So I'm not actually 100% sure why my comma isn't working, but I can find that out and post an answer. Let's check this again here. Yeah, so when I try to divide a string by 5, it's giving me the one at the bottom, not the one that it should. It should give me the type error, which would have been this sentence, but it's giving me this one. So there's something there I have to troubleshoot, and I can't figure out why that's not working, to be honest with you. Maybe if I change this to a finally. So I'm just thinking off the top of my head here, all the things I can possibly do to fix this. Yeah, okay, because it generated a type error, but it should be catching that type error right there, and it didn't. Okay, that's something I need to figure out, because clearly the comma method isn't working. So I will actually just look into that and post something later. A limitation of what we're doing right now with our try and accept is that it's allowing us to identify that we have an error, and it's not breaking our program. But we're also not giving the person the opportunity to re-enter data. So if they do make a mistake, we're telling them they have a mistake, but we're not letting them re-enter data. And as we know from our programs where we're using while and a sentinel or flag to determine whether or not the program should keep going or whether or not it needs to end. For instance, you're entering a bunch of marks, type -1 to end the program. We've got a flag set up so that the user can decide when they're done entering data, or when they're done playing the game, or when they're done doing whatever they want. And we don't know how many times the program needs to loop. We just know that we need to keep looping it until they tell us we're done. Well, if they put in bad data and it breaks our program, well, the program's done right there, right? So oftentimes when you're using this input sanitization or basically data validation, you need to have it structured in a loop so that if they screw something up, it doesn't break your program, but it also gives them the opportunity to enter data in again. And some of you have already in your programs kind of programmed around that, not using try and accept, but just saying, putting in if statements, saying, if the input is a string, then give them an error message and let them try again. If the input is not a float, or if the input's not an integer, give them a little error message and let them try again. So essentially what you're doing is you're building this try and accept process into your programs already, but now you'll have a very specific tool that's built to try and help that. So for instance, let's build some of this in a loop where let's get them to try to enter data that they can divide successfully. So the goal will be enter data, give them the answer or whatever. Give them the quotient. That's the word I was looking for. Give them the quotient. So we want them to enter two numbers that can be divided by each other, and we're going to let them enter. We're going to let them enter a string. And we're also going to let them enter an integer, and we're going to let them enter a number. And what we need to do is we have to find a way to somehow loop this so that it continues to ask them for data until it gets the right type of data. In fact, right now we're just going to do, they're going to enter a number to divide by. So we'll have a equals integer enter a number, and enter an integer. You fine. Enter a number is fine as well. We're going to turn it into integers, and if we're able to divide the integers that they give us, we're going to print out the answer, and then at the very bottom we're going to say we're going to print out program over, just to indicate that our program didn't break and it made it all the way to the end. But we're going to include this in a loop now so that it continues to do it until it gets good data. So let's just do this in a while loop because we don't know how many times it's going to take them to type in the proper data. So let's do while true. That's an easy way for us to start. That's an easy way for us to start. Oops, a loop, because we know it'll get in as long as it's true, and then we can use the break command to break out of the while we want to. So it's a way of breaking out of a while loop without using a sentinel or a flag like type -1 or type an even number or something like that. So we know it's going to get into the while. We know it's going to ask them for these two numbers, and then we're going to do a try and accept. Okay, so we're going to do a try, and our try is going to be try to print the division or the quotient of these two numbers. So we're just going to do what would be a comma divided by b comma b comma equals comma, and then we do a divided by b. So what we got here is we've used the comma method to concatenate a bunch of different data types because we've got an integer here, and then we want it to print a string, then we want to print another integer, then we want it to print another string, and then at the end we want it to actually print some math where we take a and divide it by b. So this should work fine as long as we get good numbers for a and b. If we get 1, it should give us a good response. However, if we get something that it can't do, like 5 divided by 0, then we know that this try is going to break and it's going to need to run an accept. Okay, so when it's done running the try, basically it's executed successfully, and then we can just sort of carry on with our program. So what we can do then is we can just we could break the loop, right? Because we know we can leave it. So let's break. And then down here at the bottom, we'll print. Actually, we don't need to print anything because we've already printed the answer right there. We're just going to get to our program over, and our accept is going to be we're going to print there is some problem with the data. Okay, now we're not saying exactly what problem there is with the data, but after it runs this accept, it should continue our program. Our program, because it's only breaking under the try, it should loop back up to the while and then let you enter new data again. So sometimes when I build these, I make minor errors and it turns it into an infinite loop, which is really quite frustrating because you have to stop your program and start it again. So I'm just going to copy all my information in case I made a little mistake here. All right, so let's give it a run here. Again, our goal is to get two numbers that we can divide. If we do get those numbers and it works, it's going to print out this line, and then it's going to print program over. And if we don't, it's going to give us this error and hopefully let us try again, because we've got this while true means it's going to loop forever until we specifically tell it to break out of that loop. And the only break is under the try. Okay, so let's give this another run here. Enter a number. Let's try a number that works, 5 and 1. Okay, so we printed 5 divided by 1 equals 5.0, and now your program's over. So that worked successfully. Now the real test is it going to work if I give it bad data? So if I give it a 5 and a 0, okay, you'll notice that it printed there is some problem with the data, but it also instantly popped up the input box again, which means try again, right? So so now I can try again, and I can do 5 again and 0, and it'll say, oh, there's still a problem with your data. Give me some good data. So now I go 5 and I go 1, and it says, okay, now you've given me good data. 5 divided by 1 equals 5.0, and your program's over. So there's an instance where we've made it easy for the user to recover from an error. If we don't have some sort of data validation system built into our program, if they enter bad data, it breaks your program, and that's the end of it. Whereas if you build in some protection measures, some data validation methods using these try, accept, and finally structures, then you make the program more usable, because not only is it not going to break and stop, it's going to give the user the input or the feedback that you want to give them so that they can actually put in the right data. Okay, so in this case, we told them just there's some problem with the data, but remember, we could be even more specific. So if we wanted to check if there was a zero division error, we can do that one. And then we can, because maybe we think based on our program, that's going to be the most common error, is that one right there. Someone's going to accidentally put in 0 and it's going to break our program. But just in case there's other errors, okay, we'll just build a blanket accept to catch anything that's not a zero division error, and we'll just tell them, this chunk right there is a problem with your data. Whereas if they specifically make the zero division error, we should give them some better feedback, and the better feedback might be you are trying to divide by 0. Enter a non-zero number, integer, for b. So now when we run this program, again, if I type 5 and I type a 0, it's going to give me some very specific information. It says you are trying to divide by 0, enter a non-zero integer for b, and then it lets me try again, right? Because if we know that this is likely the error that people are going to make, that this is, say, going to be 80% of our errors are people just typing in a 0 when they shouldn't be typing in a 0. Let's give them some very targeted feedback that says this is exactly the mistake you're making. Try again. So now I say, oh, well, that number can't be 0, so I'm going to make it 6, and then I get the data that then I get the output that I need to get, and it also continues my program down to the program over. Whereas if I make another error, a different type of error, it'll still catch that different type of error, but it'll give you a different response. So let's say I put enter a number, but for some reason I put in a string, and then I try to divide that string by an integer. We're not going to get the zero division error because we're trying to divide a string by an integer. We're going to get a type error, and we don't have a specific exception for type error. We've only got the one for zero division error, which means this one at the bottom should clean up everything that isn't caught by the first one. So if we try to enter a word in here, it's just going to give us the second message that there's a problem with this data message. So let's run it. Okay, so it says enter a number, but I screw up and I enter hello. And then what number should I divide by? 2. Okay, and then it just says there's some problem with the data because the error that it generated was not the zero division error. It was a type error in this case, so it gave me the blanket sort of, there's some problem, but we're not sure what it is. So just try again. And this time I read it and I say, oh, okay, I need to enter a number. And so I would enter a number. I'm not going to do that now because I've got it inputted for a string. So it would break anyway. But the whole point of this is that it goes to show that you can prepare for common mistakes that people are going to make, but you can also leave it somewhat open so that if they break the program in some way that you haven't thought of yet, because never underestimate the stupidity of the common user. They will find amazing ways to not read the instructions and break stuff. So even if they make an error that you couldn't have possibly conceived of, and it tries to break the program, if you have the right structures in place, you'll be protected from that. So it'll give them an error, even if it doesn't tell them exactly what the error is. It just says, hey, I don't know what you typed in there, but it wasn't going to work. They have another opportunity to enter good data. So it's important that you understand how some possible ways that you can use looping to get data, because it's not enough just to tell them that they're wrong. At the end of the day, for the program to work properly, they shouldn't have to keep restarting the program every time they want to do something. That's the point of looping, is it allows you to redo things and repeat things inside your program. For instance, for Scratch, it was not acceptable that for the paper, rock, scissors game, that every round you had to click the green flag to do another round. I said, build it so that it's the first 1 to 3 wins the tournament. So every round you would pick, paper, rock, scissors, but it wasn't acceptable for you to just program one round and then you have to hit the flag again to do the next round, or a new round, and hit the flag again and hit the flag again. That's bad programming. You know that you can use looping to do repeatable events, and that's what we have to do. So it is important that you understand how to loop with your try and accept to get good data. Remember that we probably don't have a lot of experience with different ways of using sentinels and while statements and whatnot, but just know this one is particularly useful. If you want something inside a loop and you need it to loop at least once, you can make it just while true and it'll get in here. The problem with this one is it will loop forever. So if you are using a while true loop, you need to have a break in there somewhere so that it has an opportunity to break out of the loop. Because if you don't have a break in a while true loop, it'll just keep repeating forever. It'll never stop. There's no way out of it. And again, your program will run until your computer runs out of memory and crashes. So it's a bit dangerous to use this, but it can be done properly if you've got a break. The same sort of error can happen if you use a flag, but it's another common technique, is that you'll have a flag equal to something. In this case, I'll make my flag equal to 0, and my program will be while flag equals 0. So this way, I'm guaranteed that it's going to work at least once, right? Because I set my flag equal to 0, and then I say, as long as flag is 0, keep doing this. So while my flag is 0, it's going to execute the while loop. And then inside your while loop, you can either have a break, which a break will work out just fine here, or you could have something to the effect of, instead of breaking, you could change your flag to 1, right? So now if my program works successfully, the try works, then it'll set the flag to 1, which means next time it tries to go up and loop, it does this check. It says, is flag equal to 0? And you say, no, I made flag equal to 1 because everything worked. Then that'll stop the while. So this is a flag, and remember, this flag is often called a sentinel. You either use sentinel or flag for the word, but it means essentially the same thing. So this is an example where instead of using while true, I used a flag. Okay, so I set the flag at 0. I know it's going to get into the loop once. If things work out properly, then I will break out of the loop using the flag equals 1, so it doesn't loop again. But I've still got my try and accept options here, which means it should catch errors. Let's see, I'm going to do the A divided by B one again and just show you how this works. Okay, so the flag is at 0. Okay, it's asking me for a number. I'm going to do a 4, and then I'm going to do a 0. And it's going to give me an error. It says you try to divide by 0, enter a non-zero integer. Okay, so let's do it right this time. I'll enter in a 5, and I'll enter in a 1, so it should be able to do this. And then it said 5 divided by 1 equals 5, program over. I'm going to step through this one using F7 step by step, just to show you exactly what's happening to our variables and exactly what line is executing and why it's executing the way it is. Oops, I didn't need to do that. So I'll step by step through it, F7. Okay, so it just sets the flag as 0, so that's just a variable, global variable, integer equals 0. It says while flag equals 0. The flag is 0, and it says while it's equal to 0, do what's inside the while statement. So it's going to go inside the while statement. It's going to ask me for a number. I'm going to put in 5. Okay, so now I've got a new variable. A is an integer equaling 5. And now it's going to ask for the b, and I'll put in a 1. So my variables will see b is an integer equal to 1. Now it's going to execute the try. So it always does the try, because that's what it's trying. So now it wants to print this variable divided by this variable equals this. So now this is where this whole try except hinges on. Is this going to be able to work, or is this going to give us an error? And as we know, because I put in 5 and 1, it should work this time. So it was able to print this. It's able to set the flag from 0 to 1, and then now when it checks again, the next time it does the loop, what we find is the flag is now equal to 1, which is not the same as 0. So it's basically saying, is this still true? Is the flag still equal to 0? And the answer now is no, the flag is not equal to 0, which means it's not going to do the loop anymore, which means it skips over everything else in the loop and goes right to the print program over, and your program's done. Now contrast that with me stepping through this again, giving it bad data. So it's doing the exact same thing it did before. It's setting the variable flag. It's going to get a number from me. I'll give it 5. It's going to get another number from me. This time I'm going to give it 0, which is bad data, we know. So it's going to try to print this, but it's going to fail. Okay? So now you see it skipped right to the except 0 division error. So the 0 division error exception, it identified that the mistake I made is this particular mistake. So it's going to give me this particular message. You are trying to divide by 0. And now it goes up to see if it can run the loop again. Now, I didn't change the flag to be 1 because it never got to this line. It didn't get to this line because the line above it generated an error. So the flag was never changed to 1. The flag will still be 0. So when it checks this and says, hey, is this still true? It is still true. 0 still equals 0. So I'm going to run the loop again. And the first part of the loop is give me data. You gave me bad data last time. Give me good data. So I'm going to enter 5. Okay. Then I'm going to enter 0 again because I made the same mistake twice. It's going to try. It's going to fail. It's going to skip down to the error. Then it's going to say you're trying to divide by 0, and then it's going to check the loop again. Is flag still equal to 0? Yes, it is, because I never got to the line that said flag equals 1. So now I do it again. Give me a number, 5. Give me a better number. Okay, 1 this time. Great. Okay, now it's going to try again. Can I do this line? And now this time it was successful. So you see it gave me the 5 divided by 1 equals 5.0, which means that this line was successfully executed, which means now I'm going to get to the line after it, which says change the flag, change my sentinel so that it doesn't loop again. And now it goes back up, tries to loop. It says, is 1 equal to 0? That's false. So now the while is over. It skips below the loop, prints the last line of my program, and your program's over. Okay, so that's how you can use try and except to try to do things. It doesn't necessarily have to be getting input from the user, but most often it is, because if people are going to make mistakes when they're entering data, you're going to have a wide variety of people entering data, and you are not always going to get the exact same data, and people are not always going to read it. So most often I would say you use it for getting data in, but you could also do it if you're troubleshooting your programs, because it'll catch programmer errors too. I mean, clearly, even if I don't get input from let's just say I don't even have this in a loop. Let's just say that I have this program. So I'm just going to unindent this. Okay, so let's just say I don't have a loop. I've just got a program. And my program is simply, I've got a hard-coded value in for this, and it's a string. So it's just going to be hello. Okay, and then I've got a hard-coded value in for b, so there's no data entry. I've just got a b is equal to 5. Okay, now if I try to divide, or if I try to print a divided by b, okay, that's just a program that I created. There's no data input whatsoever. So comment this out for now. Okay, so my program is 3 lines long. Here, A is equal to hello, B is equal to 5. I want you to try to print hello divided by 5. Okay, so that's a program that I could have created, and then at the very end, I want you to print program over. When I run it, I get an error, and you've had that happen to you probably, you know, like 20 times or more already in this class. You've just programmed something in, you've hit run program and hoped it worked, and it didn't work because you made a mistake, and it gave you an error. But you could also use this to help you troubleshoot, right? So let's say that I do have this code in my program, and I know this is a very simple thing, and you'd probably be able to identify the mistake right away. But if it, you know, let's say this is a 200-line program, and there's a mistake in there somewhere, and you can't really figure out what particular mistake it's making, or you're having trouble understanding this down here, or more, you know, probably more appropriately, you're giving your code to someone else to test. So if they get errors, you want to try to tell them why they're getting the errors they're getting. By adding some try in here, try except in here, you can help your buddy, whoever's looking over your code. You can help whoever's trying to test or change or update or whatever with your code. Try to give them a bit more feedback. So instead of just printing A divided by B, I'll put it in a try statement. So it'll be try to print A plus B. I don't need the flag anymore, okay? And then I've got a 0 division error that says you're trying to divide by 0, and then I'll put a type error in there. And that could say, you know, oops, you know, are you dividing by a string? Say Ted's the person testing my code, and you know, maybe there's another one. Maybe there's a name error. Print Ted. Did you forget a variable? And then another one, except. Maybe this will be our catch-all except here, which just prints Ted, you goofed. But I don't know where. Wow. So now I'm using my my try and accept very specifically for Ted, who's testing my code, and Ted could make some mistakes. So, you know, let's get here, Ted, check my program over. And Ted puts in 2 variables. Ted puts in A and B, and it tests my code, and it says, are you dividing by a string, Ted? Program over. It didn't break, but it gave Ted a very specific message saying, Ted, you might have messed up here, and this is why you messed up. So Ted goes, oh, okay. Great, okay, so I made a mistake. That's supposed to be a number, great, okay. I put in 2 new variables. Now I'm gonna test your code again. Oh, Ted, are you trying to divide by 0? Oh, yeah, I am trying to divide by 0. I shouldn't have done that. Okay, so I'm just gonna try and fix your code here, and I'm gonna put that in there. Ted's gonna try your code again, and Ted's gonna get the message, Ted, did you forget a variable? Oh, yeah, I forgot a variable. Oh, yeah, that's oof, my mistake. Or Ted just had some Ted just had some bad code in there. Okay. Oh, that was a syntax error. I didn't put a syntax error in there. Whoops. It's actually a runtime error. This one will give you another name error. Yep, name error variable. Okay, so I messed up, and I'm trying to generate another error here. I'm just I'm struggling to figure out one more error I can throw in there. Like a memory error you can use when you've got an infinite loop, but I'm actually a little hesitant to do that because it would require my computer running until it actually found the error. Yeah, so anyway, any other error that it generated would be caught by this final except at the end, but I told it to take care of these specific errors because these are the specific errors that I thought Ted was most likely to make. And then this one's just going to catch any other possible error when it tries to run my program. I need to have. I just want to test something here. Yeah. It wouldn't run this. Okay. I was testing something out of curiosity. So that should be enough information for you to maybe do a better job of preparing your inputs, your input statements, and for mostly for programs where you need to have a human enter some data or a word or a number or whatever it is, and you're not really sure or all that confident that they are going to follow your instructions to the letter and type in what they're supposed to type in. You can use these structures to make sure that you give them feedback and that they're able to type in data that's useful. And that should be pretty much it as far as Python. Again, the point of Computer Science 20 is to introduce you to these structures and give you some practice with these structures. I mean, we didn't really go all that deep into any one of them. And aside from your final project, you may feel like these are a bunch of little projects, but you can't do bigger, more complex troubleshooting unless you understand this these foundational structures and techniques in coding. And it's back to the you can't walk without learning how to crawl, and you can't it's difficult to teach the concept of multiplication before you teach the concept of addition. You just you got to build your way up. So hopefully some of you are interested enough in the content and the potential that you're thinking about taking Computer Science 30. And Computer Science 30 is there's going to be more sort of a graphical interface, more libraries. You're probably going to be using you're going to be dealing with bigger sets of external data. For instance, I mentioned that like DNA project where you're going to be taking, instead of having a user input things with a keyboard, you're going to be actually linking and drawing information from files and other programs into your Python, and then creating temporary lists and doing processes on the data. Maybe you're looking for certain numbers, maybe you're looking for certain strings, maybe you're doing statistical analysis, and then preparing some sort of report that again you would export to another program so that it prints out all nice. Because your job is going to be taking data and taking real world problems and building a programmatic structure that takes that data, analyzes it, breaks it down, finds the important stuff or computes the important stuff, and then prints out something that a normal human being can read that's useful. So just think of it this way: the boss comes in with a stack of papers this high. Boss says, I need you to isolate this much information. I need you to count all of the people in this file named Ted. And then you can take that, this is a digital file, by the way, you can take the 100,000 pages of digital file, bring it all over to Python, create a program that searches for all the TEDs and finds their addresses or something. So you've compressed your data to this, take that information, build a little report that says, okay, here's the number of TEDs and here's their addresses, export that to Word or something like that, have print it off, put it on the boss's desk and say, here you go, you gave me, 300,000 pages of nothing, of random stuff. I gave you 4 lines that you needed. My program did the rest, and that's why you're a valuable person. That's why you are an asset to the company, is because you can take that and you can build something to solve the problem and also export it and present it in a way that they don't have to be a computer science expert or a programming expert to use whatever you gave them. You gave data and you prepared it in a way that it's useful for them, and they don't have to understand the programming aspect. That actually comes up in your computer history assignment, the concept of abstraction. The further people are, the further abstracted they are from the very technical details of programming or machine language or binary or mechanical or electrical, the better job they can do of solving bigger problems. If you have to worry about ones and zeros when you're trying to solve a real world problem, you never will. Okay? You have to, the programs, the machine language is built on top of the hardware. Our coding languages are built on top of machine language. Other programming languages are built on top of other programming languages. Websites are built on top of that. And essentially at the end, you get it so that a sort of a regular person can ask a computer something, and that request comes through all these different layers of abstraction down to the most detailed level, and then it goes back up to the outside, and the person gets the answer they're looking for, or solves the problem they were trying to solve. They don't need to understand everything all the way down. They just need to know how to work at the top level. And then all the other layers of abstraction are the things that are taking care of those details. I think I used an example the other day of you can drive a car without understanding how a transmission bearing works. Okay? You don't have to know exactly how your transmission works in order to drive a car. Okay? You say, I put it in drive and I put my foot on the gas pedal and the car goes. That solves my problem. I don't want to walk everywhere. But you being able to drive a car does not require that you understand internal combustion or you understand how the transmission works. You're abstracted from those details, and that's what makes it useful for you as a regular human being. Otherwise, any problem that you wanted to solve or anything you wanted to do anywhere in life, you would have to have all sorts of very specific technical information in order to do anything, and no human is capable of retaining that level of information. Okay, now I feel like I'm getting to more of the philosophical aspects of programming and computer science, so I will call a halt. Are there any questions for me?
I have one.
You have one. What's that?
In the practical portion of the exam, you mentioned something about some sort of graph function.
Graph function?
Yeah, some sort of like function.
Like this one? Graph? Like that? Or
yeah.
chart? You probably meant chart, right?
Yeah, I think so.
Yeah. So I know what you're talking about, and what that would refer to is just building the chart of because both of those programs rely on you printing out something at the end, right? It has to do with random numbers. One of them's with dice, and one of them's with I'm struggling to remember what the other one is. Is it one of them's with dice, and the other one's with a random number between 0 and 100 or something like that?
Yeah, I think it was just like counting occurrences of a certain number.
There it is. Zane said random numbers between 1 and 500. So either one of them, you've got these rather large data sets, but you have to present that in output at the end. And I want your charts to look like mine. So one of the recommendations was to have a function that builds the chart. So you send the function the data, and maybe it formats it. Maybe it formats it this way. You know, maybe there's that character. And oops, that's a bad example. That character, and then dice roll 1, and then 12, and then 33% or something like that. I can't remember exactly what the statistics stand for or whatnot. But let's say you're supposed to roll the dice 100 times. After you send the data to your chart function, perhaps it's a void function that prints out this line, so that it makes it look good when you do it again. Let's say the next line, once no one types anything, dice roll 2, and then the next line, and then maybe you rolled a 10 that time, and then maybe that was 12% or something like that. So that it's building the chart. Okay, this last one doesn't exactly line up, but you get the idea where you're sending the data to a function so that it builds the chart and just formats it so it looks nice.
So how would you send the data then?
That's how you send data to a fruitful function, is by sending it through as an argument. And just flip over to, you've been doing this before, so this is nothing new. Second here. You see my Python?
Yeah.
Okay, so let's for instance, let's just say that let's def graph, and it's going to accept 3 numbers. Okay, so it's going to accept an A, it's going to accept a B, and it's going to accept a C. Okay, and actually we'll say the C is a string. Okay, so in here we're gonna build the graphing function, and then down here is where we're going to send it the data. So let's just send it for whatever reason. Let's send it A equals 5, B equals 6, C equals hello. Do it differently than this. C equals A plus B. Okay, I'm going to go a little further in this than I originally intended to, because I do believe it is valuable. Okay, so let's just say that the goal of this is going to be that we roll dice and we print out the sum, each die, and then we print out the sum of the dice. So outside of my function, I might have something to the effect of a lot of this, this is, trial and error sometimes too. Let's say that this is die1. Printing something. Let's say die1, and then this is die2. And this is total. And you can use tabs for this. I think I reference in that assignment or in that question. Okay, so there's the top of my chart, and ultimately underneath it, I want to have my data nicely organized. So let's just create a quick little loop here that allows us to input data, and then it'll send the data to the graph function that'll add things to our to the start. Like this is just our title row for the graph, because I don't want that to happen every time it loops. Otherwise, we just keep getting that over and over and over again. I just want to have this at the very top, and then I want to have all my numbers underneath lined up and formatted appropriately. So let's do well, true. Actually, I'll do a flag on this one. Global variable should put it at the top. Flag equals 1, 0. So while flag equals 0, we're going to do this. We're going to get input. Sorry, I'm building this on the fly, so I'm just kind of thinking to myself, let's import random. So we can actually just generate a random number. And I won't make these dice, I'll just make these numbers. Okay, so here's number 1. Here's number 2. And there's the total, so we'll add them together. So while flag is equal to 0, we are going to generate a random number. So A is going to be equal to rand int 1 and 10, let's say. So it's going to be a number between 1 and 10. It's going to do the same thing for B. Equals rand int 10. And then C is always going to be A plus B. Now what we want to do is we want to send these to the graphing function and have the graphing function build the rest of this chart. So while flag is equal to 0, we're going to get a random integer, another random integer. We're going to add them together. We have to have some way to stop too. So we need to change the flag at some point. So let's, how can we handle that in here? Because we're getting a random number there. We're not getting any inputs. Okay, so maybe this would be an instance where we would put in a, sorry, just thinking off the top of my head here. Let's do this way. Let's generate 2 random numbers between 1 and 100, and if C, so if adding those 2 numbers together equals 50, then we'll have our program stop. Okay, so if C equals 50, if C equals 50, let's break out of our loop, and then the program's over. Okay, so that's really what all we're going to do. We're going to have a program start. It's going to go really quickly because there's no input from the user. It's going to generate 2 numbers between 0 and 100. It's going to add them together. If the number is 50, the program's going to be over. If the number is not 50, it's going to send that data up to our function. Okay, so this is really the important part of what you were asking. So if C is equal to 50, the program's going to stop. The loop's going to stop, and the program's over. If it's not, we're going to send the data up to the function so that it can actually produce something. We're going to make it a void function this time because it doesn't really need to return anything to the else statement. It could, but in this case, it's not strictly necessary. So what are we going to send it? The function was called graph. So what we're going to do is we're going to access graph, and we need to send it for 3 things, right? So we need to send it A, B, and C. We can just send using commas. Now we're sending 3 pieces of data. We have to be prepared to accept 3 pieces of data. And usually you don't name them the same thing. So when A is sent up as an argument, it's going to be called num1. When B is sent up, it's going to be called num2. And C is going to be called total. So those are the local variables that will be used for the rest of the function, but nowhere else. So what do we want to do with these numbers? It was pretty simple. We wanted to print, and then you try to keep this format as much as you can so that things line up. And again, you have to play with it a little bit because formatting is not the easiest thing in Python. So we're going to print, instead of number 1, what we're going to do is we're going to replace this whole chunk with whatever, that's num1, right? So, whoops. Okay, so now I need a little chunk of string here, and then I need to put in a comma, and then I need to put in num1. Okay, then another comma. Okay, then this needs to be a string, and then instead of number 2, we need to put a comma, and then we need to put the variable num2, and then we need another comma, and then we need to put that in. So then we get to the total section, so we need another quote, another comma. Then instead of total, we want to have the variable total, another comma, and then the rest is just characters. So I've combined a bunch of strings and a bunch of numbers, in this case that they should be integers, together in one print statement using a comma. So it's going to print out, for sure, it's going to print out that vertical bar and then an underscore, and then it's going to put a space, then it's going to put my variable, then it's going to put a space, then it's going to put this little chunk, then it's going to put a space, it's going to put the number 2, whatever that is, then it's going to put space, then it's going to put that. Anyway, so I'm just trying to format this so it's somewhat similar to this chart over here. And I will probably have to play with the spacing a bit. So that is all that this graph function needs to do, because I made it a void function. Instead of it having to return something down here, it's just taking this and it's creating the data for this. Now, to be perfectly honest with you, this is not a great use of a function, because there's no reason that I couldn't just put this line right inside my else statement. Okay, I'm just formatting data right now, and I'm showing you how you could do it with a function, but this wouldn't be a situation where necessarily it's the best use of a function. I will be perfectly honest with you. Several of the assignments that I've given you, the programs in the assignments, I have specifically asked you to use fruitful functions. I've specifically asked you to use void functions. This is not necessarily because that program or that particular problem really benefited from having a fruitful function. The point of it is you get practice with fruitful functions, so that when you do run into bigger and more complex programs, you've got enough understanding of how they work and how to set them up that you're able to complete it. There's no sense in me throwing you into the deep end of a pool and saying, here's a big program that's really complex that really needs a function, go for it. It would just be too confusing and too stressful for most people. So we start out small, and I get you to put in fruitful functions and void functions in situations that probably don't need them, but that are simple enough that you can practice with them. So I do need you to keep that in mind when you're going further in computer science and you're looking back and you're saying, well, why did I build all those stupid little functions for those things? They didn't need them. I agree with you. They didn't need them. Therefore, practice. So with that being said, we're using this graph function. It is indeed a void function because it doesn't return anything. The only thing it does is it prints this line, and this line is going to be different every time because num1, num2, and total are going to be different every time. So this program is going to loop and build this chart until total equals 50, and then it's going to stop, and we'll just see what we got left over. And a lot of times, this is the way it works with formatting. You try it, and then you adapt and go from there. So let's run the program and see what happens. Oh, I guess I should probably import random the right way. Okay, it says rand int is not defined. Oh, import from random import star. Sorry. Otherwise, I have to use dot notation. Okay, so I ran it, and it looks like it had to go quite a ways in order to generate a total of 50. Now, look at my formatting. It's clearly terrible right now. Number 1 is under number 1. Number 2 is way over. Number 3 is way over as well. This isn't looking so hot. So let's try and maybe fix this, and let's do it a little differently. And there are all sorts of specific ways of formatting, and we don't go into that. There are like string methods and things you can do to format so that it's the center of a block and center spaces, if it's aligned to the left, if it's aligned to the right. We don't have time to go into that in this course, so a lot of it's just going to be kind of manual trial and error on this stuff. So let's try this with tabs instead. So tab is a special character that's /t. So instead of putting in this, I'm going to put in /t/t. Okay, that just means tab, which is the indent, right? So /p/t. Hopefully I've got the right one. /p/p. Let's see what happens. And do I need one at the end? Yeah, /p/p. So let's see what happens here. Run it again. Wrong slash. I always do this. I forget which way the slashes go. I think after all these years, it would just be automatic. Okay, let's see what happened there. Okay, so now I ran it slightly differently, and now I've got the other problem. Okay, so I've clearly got some space here. This is a single-digit number, which obviously impacted it a bit, and so it's better, but it's still out of whack. And you know, so I could play with it a little bit more. Maybe I put one tab in instead of two. Play with it. It doesn't take much time, right? Okay, so here's my new chart. I'm going to change the numbers because it looks like my charts are huge. Okay, so maybe I'll put it 1 to 20 instead. It won't take as long to find a matching number. Let's say if A plus B equals, let's do 25 this time. Shouldn't take as long. Okay, so there's our charts, obviously much smaller. This one looks to be lined up pretty well. And then we got a problem here. So what else could I do there? Might make sense to do something like this here. I'm really just thinking off the top of my head right now. This is honestly not that important. This is all just formatting your data so that it looks the same as the header row. But as you can tell, I'm clearly invested in this process right now, so I need to get it so it looks at least half decent before we sign off. I'll do that, and let's see what that looks like. 10, 2, 12, not great. Not great. I still have underscores. Oh, because that wasn't my last version, that's why. Okay, there we go. So another tab on this side. You could also put spaces in there too. I mean, really, it's just trivial, semi-trivial data organization at this point. It's just the way it looks. It's got nothing to do with what the data actually is. Yeah, so that's not looking great. Might be better to use spaces. And by the way, you could very easily Google those layout examples, like I told you, those methods for strings where you can line things up by center within a certain number of spaces, or you can change all your data, all your numbers into strings, and make it a little easier to work with than perhaps always using them as, for instance, like total up here will be an integer. There's no reason you couldn't print it out as a string instead of an integer. It's still going to say whatever the number is. It's just you won't be able to do any more math on it, which you don't need to do because you've already added them. So instead of printing total, you could just as easily print the string of total or the string of number one, because all the math has already happened by this point, or the string number one. So it doesn't matter. It's going to look exactly the same, but it might be easier to format with strings. And it's still not looking great, but play with it. Play with it. Eventually you'll get it so everything kind of lines up properly. And again, it might be the easiest thing, might be just to Google quickly the some of those formatting options built into Python to center it, or to make it left aligned or right aligned. It might make it easier for you to do, just to make the chart look nice like the ones I built. And for some reason, Yeah, see, like this looks nice, but in this case, the data is all on this side is always 2 digits. As soon as you got into the 1 digits, then you see there's a bit of a problem there. Okay? And you could build an if statement for that too. You know, if the length of this particular string or piece of data is 1, then add 5 spaces. If it's 2, then add 4 spaces. I mean, you could build logic in to do that, but I also believe that there is a very easy way of centering things within a specific section of a string. It's a string method. It's probably a dot notation, dot center or something like that, but I can't remember what it is. And it's always perfectly okay to Google it and find out. There's something you want to do in Python and you think you should be able to do it because it makes sense, and you can't forget, you forget how to do it or you've never done it before. Chances are somebody's already built something for it, so go out to Google, go out to Stack Overflow and learn from it. And I'm not saying copy and paste and steal people's stuff. I'm just saying a lot of that stuff is shared because people ask questions and other helpful people who are experts want to help them. And that's information that you should be using to improve your knowledge as well. And I do all the time. For instance, I will, as soon as I sign off here, I will probably go find out which one of those ones helps me easily center within a space in Python, so that hopefully I remember it next time I do one of these. Okay, does that somewhat answer your question? I know, as usual, I kind of got a little bit off track there.
Oh yeah, because I thought it was some like built-in function. So.
No, it's not a built-in function. In fact, I might, if it indicates that anywhere, I might go into that question and just make it clear that no, this is, you know, build your own function. The whole purpose of this function is just to display the chart or print the chart or make it look nicer or something like that. Fair enough?
Yeah, thank you.
No worries. Any other questions? If not, we'll sign off for the day.